Today we're going to be learning how to graph a polynomial function. So a polynomial function is just a sum of power functions. So a whole bunch of power functions put together. So information about the graphs of polynomials. They're always going to be smooth and continuous. So there's never going to be any breaks, gaps, holes, or sharp turns. And it's always going to be from negative infinity to infinity for your domain. Now the end behavior of your polynomial will always look like the power function of the same degree. So what this means is any odd polynomial is going to look like the cubic function, which is x cubed. So for example, if you have a positive function, so it looks just like the parent function of x cubed. So it starts at the bottom and then goes up. Whereas if it's a negative, so which means it's been flipped across the x-axis, now it's going to be going the opposite direction. So this is what it looks like if it was flipped across the x-axis, right? X-axis reflection. Any even polynomial is going to look like the quartic function from yesterday. So again, if it's positive, it's going to look like our parent function, which just means it's going up on both sides. But if it's negative, again, it's flipped across the x-axis, so now it's going to be opening down instead of up. So that's what the end behavior of your polynomial will look like. What we're going to be using to draw our polynomial today are the roots. So the type of root is going to tell you what the graph looks like at that point. So there's three types of roots we're going to look at: a single root, a double root, and a triple root. So single roots look just like our parent function for x, which is the linear parent function. It just goes straight through that root. So just like our parent function for x, which is a line, it's going to go straight through this line as well. So if you have a root right here, it's just going to go straight through. If you have a double root, this is now going to look like x squared, our quadratic function, which is a parabola. So what happens on a double root is it's going to bounce off at that root. So this is your root right here. It's going to bounce off. So it's either going to look like this, or it could look like this. So either way, it's going to look like a parabola. It's going to bounce off the graph at that point, like a parabola. And finally, our triple root, which is going to look like our x cubed function, our cubic function, it's going to curve through it. So again, it's going to resemble our cubic function, where if this is my point, it's going to make a little curve, just like my cubic parent function. Or it could go in the opposite direction, of course. So it's either going to curve up or curve down, like that. So knowing this, now we can draw any function just by knowing its degree. So is it odd or even? And also what type of root each one is. So this is all you need to know. This is the important stuff for today's lesson. Okay, so let's take a look at some examples. So if we look at number 1, first thing we need to do is figure out what the roots are. So the roots are, if we set this equal to 0, what are our x's? So of course x minus 2 equals 0. You add 2 to both sides. One of your roots is going to be 2. For this one, what's your root of x plus 3? It's going to be negative 3. So in this case, we have 2 roots. So this is a degree of 2, because there's 2 roots. Obviously, 2 is an even function, or 2 is an even number, right? So this is an even graph. Also, to figure out whether it's positive or negative, we're just looking at the very first number here. Is there a negative sign in front of it? No. So it's positive. So if it's a graph that's even and positive, it's going to look like our quartic function that's positive. They're both going to be pointing up. So that's what the end behavior is going to look like for this. Now we're going to plot our roots. So we know we want to root at 2. So we want it at 2, and then we want to root at negative 3. Here's negative 3. And so we know that on both sides we want it to be going up. Both of these are single roots because there's only one of them. And we're going to do an example in a bit that shows more than one. Both of these are single, so what that looks like, it should go straight through your graph. So this is, we know you want it pointing up on both sides. We want it to go straight through this one and also straight through this one. And so it looks like a parabola, which makes sense because it's a degree of 2. Right? Degree of 2 is a quadratic function. Let's look at number 2. So again, let's first find our roots. Our first one comes from this x. So x is equal to 0. What is my root from x minus 4? It's just positive 4. But be careful, you see how this is a squared right here? What this means is that it's actually x minus 4, x minus 4. Right? So there are actually 2 roots of 4. Right? So there's actually 2 different roots at 4. This is where we're now using our double root because there's 2 4s. This is a double root, whereas the 0 is still a single. So again, let's first count. We have 1, 2, 3 roots, so this tells me it's a degree of 3, which is odd. Let's look up here. Is there a positive or a negative in front of it? There's no negative, so this is positive. So if it's an odd and positive, we know that it's going to look like our cubic positive graph. So it's going to be starting down here and then moving up. And again, let's plot our points. So we have a 0 and a 4. So we wanted to start down here. Because the 0 is a single root, it's going to go straight through it. But 4 is a double root, so because it's a double, it's going to look like our x squared, so it should bounce off. So what this means is it's going to bounce off as if it was quadratic, and then keep on going up, because that's the other end of my graph. So that's what my graph looks like for number 2. Okay, let's move on to number 3. So same idea, let's look at our roots. We have 2, and it's 3 of them. Right, so this is a degree of 3. It's odd. This is the first time that we now have this negative sign. So it's negative, which means that it is going to look like this. Starts up, goes down. We only have 1 root here. It's at 2. And this one is a triple root. So because it's triple, we know it's going to curve through just like the x cubed function, which makes sense. This is x cubed. We wanted to start up here. I'm going to curve through and go down. That's the only root, so that's my graph for this function. Easy peasy. Okay, let's look at number 4. Let's start off with the x squared. My roots are, I have x squared gives me 2 zeros. The x minus 4 squared gives me 2 4s. My degree is 1, 2, 3, 4, so I have 4 roots, so it's even. Let's look at the function. There's a negative out front, so this is a negative even function. Negative even function means that now it's going to be pointing down. Both of these are double roots. So 0 and 1, 2, 3, 4. Both of them are double, so both of them are going to bounce off like a quadratic. So I know I want it to be pointing down to start off with. It's going to bounce off this one, and still be pointing down. So when it's a double root, it doesn't go through it, it just bounces off. That's my graph for number 4. Okay, let's look at number 5. Again, let's start off with our roots. We have a 0, a 1, and a negative 4. So this is a degree of 3. It's odd. Anything in front of it? Nope. So it's positive. An odd positive graph is going to look like this. So I know I have a root at 0, a root at 1, 3, 4, a root at negative 4. All of them are single roots. So all of them are going to go straight through. So I'm going to start down here because I know I wanted it to start down here. I'm going to go straight through the negative 4, straight through the 0, straight through the 1, and just go point up because at the end of it should be going up. Okay, let's look at number 6. So this one's a little bit different than the other ones we've done because we have to first factor. So what can we divide both of these out by? We can take out a negative. Also, we can take out how many x's. This one has 4 x's, this one has 3. So we can divide out 3 x's, x cubed, out of all of this. So if I took out a negative, this is now going to be positive. X fourth to the 4th divided by x to the 3rd leaves me with just 1x. Again, a negative divided by negative, this is now a positive. X 3x cubed divided by x cubed leaves you with 3. So first we're going to factor it. And now same idea, let's write our roots. We have 0 3 times. We also have a negative 3. So my degree is 4. It's an even function, but this negative out in front tells me that it's going to be a negative even, which means it's going to be pointing down, opening down. So my two roots are, I have a 0 and a 1, 2, negative 3. 0 is going to be a triple root, whereas negative 3 is going to just be a single one. So let's start with the negative 3. I know I want it to be pointing down. The negative 3 is going to go straight through. But for my 0, a triple root looks like x cubed. So I want it to curve down like the x cubed function. So it's going to look like this. It's going to curve through it because it should resemble the x cubed function, our cubic function. But just like our picture, they both should be pointing down. Okay, so 2 more examples with the factoring. So let's flip the page. Let's look at number 7. So again, let's factor. What can we take out of all 3 of these? We can take out an x squared. So x to the 4th divided by x squared gives me x squared. Minus x cubed divided by x squared leaves me with x. Minus 20x squared divided by x squared leaves me with 20. So I took out an x squared. Now this is a trinomial. So what I want to do here is figure out x box. Well, it multiplies to give me negative 20, adds to give me negative 1. 4 and 5 multiply to give me negative 20. Which one do I want to be negative to give me a negative 1? The 5. So this can factor down into x plus 4, x minus 5. So once it's factored out, my steps are the same. My roots are, I have 2 zeros, a negative 4, and a positive 5. So my degree is 4. It's an even number. Let's check out what's out in front. Nothing, so it's positive. It's not negative. So even positive means that it looks like this graph. So it should be going up on both sides. Okay, let's plot our points. So we have 1, 2, 3, 4. This is 5. 2, 3. This is a negative 4 and 0. So the 0 is a double, but these two are both singles. So let's start over here. We know we wanted to start at the top here because we wanted to be pointing up on the left side. Negative 4 is a single root, so I'm going to go straight through. 0 is a double root, so I'm going to bounce off. And then 5 is again a single root, so straight through. And that's my graph for number 7. Last problem for number 8. So whenever you have 4 terms like this, the way we are going to factor is by splitting it into 2 separate terms. So let's first look at these two. What can we take out of both of them? X squared. This leaves me with x minus x squared divided by x squared leaves me with 1. What can I take out of both of those? A negative 4. When I take a negative 4 out of 4x, it leaves me with x. When I divide 4 by negative 4, it leaves me with minus 1. And I know I did this correctly because you should be left with 2 of the same term in here. So those two are the same. So since they're the same, we can just pull that out. We're factoring it out in front. And what we're left with is x squared minus 4. And we can factor this out again. X squared minus 4, difference of squares. So this is x minus 2, x plus 2. And now it's completely factored out. Again, we can go to our roots. So our roots are, we have 1, 2, negative 2. Degree of 3, which is odd. Let's look out in front. It's still a positive. So odd and positive should look like that. So our points, so we have 1, 2, and also negative 2. All 3 of them are single, so they should all go straight through. So on the left side, it starts at the bottom, straight through, straight through, straight through. And this is my graph for number 8.